So to last meeting, we did some introduction and talk about about what is chemical bonding and such. So chemical bonding. Okay, so my first question is, we need to understand what is chemical bonding, correct? So Anivia, can you read the definition of chemical bonding for us?
Chemical bonding definition. Chemical bonding is the process where atoms join together to form molecules and compounds.
Okay, so yeah, so basically what it says is that what is chemical bonding? So chemical bonding is a process where different atoms join together to form a molecules or a compound or matter. Okay? So the next question is, why do atoms bond? Tambah sa ida maka atoms ni presisnya halo bonding o halo ligação ida. All right, so the question becomes, why do atoms bond? Right, so the straightforward answer is yes. Atoms bond because they want to become more stable. Okay, so what do we mean by an stable atom? When we say a stable atom, we mean to say that the atom wants to achieve a full outer electron shell. Yeah, this atom, when like I said before in last week, I said everything in nature wants to be balanced or wants to be stable. Lah buat hotu nebe iha natureza ne hakarak iha balanso no hakarak iha stabilidade ida. No átomos mos hanesan hotu. No átomos atu alcançam minha estabilidade ne makaliuhusi bonding. Bahira átomos ne la estável, Antônio tem que buscar maneira ou insa para tu halo estável, no maneira ne mas tem que halo ligação química ou bonding. No saída mak bonding ne para objetivo ni halo bonding ne para atu hetang kata ni electron share da paling ikus ne ia rua a full ne bahira ita kulia full ne ni tweet ia there's two rules that dictates whether or not an atom have a full electron shell. One is the octet rule, where a full electron shell has 8 electrons, okay, in its outer shell. That's what we call an octet rule. Okay, duet rule falinene, you have 2 electrons in its outer cells, and only elements lithium, hydrogen, and helium follows this rule. Okay, only lithium. E depois elementos hidroxílico follows octet rule. The only 3 elements that follow duet rule is lithium, hydrogen, and helium. Okay, ¿todavía comprende todo? All right, so what is octet rule? Octet rule na sayda. Sa natin sayda mo octet rule. Jennifer Pinto, what is octet rule? Can you read this definition of octet rule for us?
Okay, sure. Octet rule is an atom tend to bond in a way that gives them 8 electrons in their outer shell.
Okay, so basically what it says is that octet rule is where an atoms bond together in a way that gives them 8 electrons in their outer shell. Octet rule ni katak rule ida nebe atomos o yang diyan sana atomos ida ni karak halo ligação para to stable no ni karak iha outer shell ni iha electrons walu. Los la outer shell ya, shell nebe paling ikus ni walu. Okay, nebe Hanesane, agora, por exemplo, e átomo sódio ni outer shell e electrons ira.
Onji.
No, that's the atomic number. Atomic number of sodium is 11. What is how many electrons in the outer shell of sodium atom? How many electrons?
Thank you.
It's 1, correct? It's only 1 electrons here. So for example, if you see here, okay, if you see the electronic configuration of a sodium atom, you have 1s2, that's the first energy level. You have 1 and s, so 2 electrons. So this is why you have 1 here and 1 here. So you have this circle over here, 2 electrons over here. but this is not the outer shell, correct? And then the next one is you go from 2s2 and then 2p6. So 2 energy level is you have 8 electrons. That's why you have this circle over here has 8 electrons. Ini hari-harinya be cursor miang nih galai. Okay, so this is the circle with 8 electrons, but this is not the outer shell, right? But you also have 3s1, where the third energy level here, you only have 1 electron. So 1 electron is in this circle. So that means sodium atom has how many electrons in its outer shell? 1, right? Sodium atom has 1 electron in its outer shell. Okay, now what about the chlorine atoms? Chlorine atom has an atomic number of 17. Okay, so how many electrons in chlorine's outer shell? Outer shell of chlorine, how many electrons?
5.
Hira?
5.
7. Because you have 1s2, where you have 1 indicates your energy level. So this is this one circle over here. You have 2 electrons over here, 1 here and 1 here. This circle is only have 2 electrons on it. Right? That's 1. And then you have 2s2 and 2p6. And then you go to the second one. This is 8 electrons over here. If you count this dot, the total have to be 8. And then you go to the next one to energy level 3. So you have 2 plus 5, this is 7. So that's the outermost shell. This is the outer shell. You only have 7 electrons. So you only have 7. So what happens if sodium atom is only have 1 electrons, but he wants to have an 8, correct? So in order to reach 8, you need to halo bonding. Karena isang mo sa chlorine atom, niya to toy had 8 or octet rule. Thank you, halo ligasan kimika. Please close your microphone if you are not using it. Okay, so jadi yang sekarik niya outer shell electron is not octet, it's not 8, then it has to have bonding. Niya tem que halo ligação para niya tem que para niya iha balanço stable, that's all atoms hotu iha periodic table ni hanya hotu kersa. All atoms in the periodic table is the same. Comprende to? Comprende galera? Okay. Now, the same thing with duet rule. Now that you already have an octet rule, the same thing with duet rule. So if you look at the hydrogen atom has only 1 electron. So 1 electron means it only have 1 electron in the outermost shell, right? This is just 1 over here that you see. Over here, right? And then the same thing with helium. Helium is a noble gas atoms, right? So because helium is a noble gas, it has an atomic number of 2. The electronic configuration of helium is simply 1s2. So you will say that helium has 2 electrons in its outermost shell. So this is 2 electrons, right? Now the same thing with lithium ion. Lithium atom has an atomic number of 3. And the electronic configuration is 1s2 and then 2s1. So 1s2 is 1 and 1 shell. So this is this one. And then 2s2 is just 1 over here, surrounding over here. All right, that's octet rule and duet rule. Okay, so duet rule is only 3 atoms follows that. Hydrogen atom, helium atom, and lithium atom. Okay. Now, what is valence electrons? You already know what is a valence shell. Valence shell. And understand fully what is a valence electron. So basically, Imelda Alves, can you read the valence definition of valence electrons for us, Imelda, please?
Electron in the atom's cell energy level of an atom.
Repeat. Do it again, Imelda. This time do it slowly.
Electrons in the atom's cell energy level of an atom.
Outermost shell. Repeat after me. Outermost.
Outermost shell.
Yes. Electrons in the outermost shell of an atom or energy level. Okay. Now, if you look at the sodium atom has how many atomic number? You have 11 atomic number, yeah? You get this in a periodic table, by the way. You can get this in a periodic table. Now, sodium atom has 11 atomic number. So if you look at the electronic configuration of the sodium atom, you will see that you have 1s2, which is 2 electrons in the first energy level. This is this circle over here. And then you have 2s2 and 2p6, the total or the second energy level. You have 8 electrons, which is this circle over here. And then you have 3s1, third energy level. So your valence shell is 3s1 shell. This is the 3s1 shell. So in the 3s1, you only have 1 electron. Therefore, your valence electron is simply 1. Okay, the same thing with chlorine atom. Chlorine atom has an atomic number of 17, right? So electronic configuration is 1s2, which is this circle over here. And then the second shell is 8 electrons, 2s2 and 2p6. So which is this one, right? And then the third energy level is 3s2 and 3p5, which the total makeup of 7 electrons. So the valence shell is what? The valence shell is the 3s2 and 3p6, right? So the third energy level. So we have how many valence electron in chlorine atom?
7.
7. You have 7 valence electrons in chlorine atoms. So this is the periodic table that using color to indicate how many valence electron in each atom is. Okay, so for example, this color over here is corresponding to this color, right? So it has 1 valence electrons. Okay, so this color over here, this is the atoms with valence electrons of 2. Okay, this color is this region over here. The valence electron is vary, yeah, it's between 3 to 12. It can be, so this is between 3 and 12. Okay, so this color over here, this color, boron, aluminum, gallium, indium, and thallium here over here, this is number 3. It has 3 valence electron with this color over here. Okay, and then carbon, silicon, germanium, tin, and lead is this color, which has a valence electrons of 4. Okay, so you can print this periodic table if you want, so that it makes it easier for you to look for valence electrons. Okay, so you can print this so that when you say, oh, what is the valence electrons of nitrogen? So nitrogen is this region over here, this color, which has a valence electrons of 5. And then if you look, oh, what is the valence electron of indium or iodine? Iodine is here in this color where you have a valence electrons of 7. Okay, so for example, this one, neon. Neon is this valence electron, neon, argon. So this is 8. So this is already 8, or this everything here is already followed. This is octet rule. Everything here already follows octet rule. And this one is already follow a duet rule. That is why all of this group is what you call a noble gas. They don't need to make bonding anymore. They are already stable. That's why you call noble. They are noble gases. Yeah. Any questions so far? Ya perguntas, Ruma? Ok, ya perguntas, Ruma? Husudet, ya. Sekarang kau explica ela, mas ya perguntas mo, si mi bele stop how? Bele husu perguntas, okay? It's fine. I don't mind. Any questions? Jennifer, do you have any question?
No, sure.
All right, cool. So now that you understand valence electrons, now let's study about Lewis structures, okay? So basically, Lewis structure is just to represent the atom with a dot. Okay, so for example, if you look, sodium has a valence electron of 1, correct? So basically, Lewis structure, you just write the letter Na to represent the sodium atom, and then you just put 1 dot over here. This 1 dot indicates 1 valence electron. That's what Lewis structure means, okay? This is the Lewis structure, yeah? This is for sodium atom. Okay, Lewis structure. And for example, for chlorine atom, you have valence electrons of how many? 7, right? So 7 Lewis structure. So the Lewis structure is you just write Cl to represent the chlorine atoms. So you write 1, 2, 3, 4, 5, 6, 7 to indicate a chlorine atom with 7 valence electrons. So this is the Lewis structure. This thing over here is what you call a Lewis structure. Hold on, give me a second. Okay, I wanna make this a so this is what you call a Lewis structure. Okay, hold on. Oops. Okay, can you see my screen now? Still see my screen?
Yeah.
Okay, so basically these two things is what you call a Lewis structure, yeah? So basically Lewis structure is you have a dot, you're using dot to indicate the valence electron of a specific atom, okay? Understand? Comprende?
Yeah, completely.
Okay, so there are, so in terms of types of bonding, yeah, so basically there is 3 types of atomic bonding, okay? One is what you call an ionic bonding, where you have electron transfer between them. Okay. So in ionic bonding, if you look at the color, so the ionic bonding occurs between a metal and non-metal atoms. Yeah. So metal and non-metal atoms, you should understand by now from our previous classes. So metal atom bonded with a non-metal atom, that's what you call an ionic bonding. Okay, we're also having like what you call a covalent bonding, where the electrons is shared between them. Or for example, this is the bonding between a non-metal to a non-metal. Okay, non-metal bonding to a non-metal, that's what you call a covalent bond. There is also another bonding, what you call a metallic bonding. That is a bonding between 2 metal atoms. Okay, when 2 metal atoms is bonding, that is what you call a metallic bonds. When you have non-metal bonding to a metal atom, that's what you call an ionic bonding. When non-metal bonding to a non-metal, that's what you call a covalent bonding. Comprende, guys? Good. So that means no questions. Awesome. Okay, what are ions? Okay, so basically, ions is the charged atom, the atom that has lost or gained electron, has a positive or negative ion. So when an ion with a positive charge, you call that a cation. When an atom with a negative charge, you call it what? Anion. Okay, so basically, what I want you to see is that when you see a positive, that means atom is losing an electron. When you see a negative, an atom is gaining an electron. So what do we mean by that? So basically, if you look at an oxygen atom over here, right? So what is the valence electrons of oxygen atom? Huh? What is the valence electrons of oxygen atom?
And
6.
ion.
What is the
Negative
valence
2.
electron?
6.
6.
Okay, oxygen atom has 6 valence electrons. So when oxygen wants to be balanced or to follow octet rule, which one is easier, to give out 6 electrons or to receive 2 more electrons? It's easier to receive 2 electrons than give
2
off
electrons.
6 electrons, correct?
Yes.
Então, niya tenki, what said that? Gaining an electron. It needs to gain 2 more electrons. So, by here, gaining an electron is a positive sign or negative? When you see a negative, it's gaining an electron, so therefore it's a negative. You call that an anion, because it needs to gain 2 more electrons to balance to follow the octet rule. Comprende to? Comprende que le?
Comprende, teacher.
Okay, what about the sodium atoms? Sodium atoms. How many valence electron is in the sodium atom?
1 electron.
1 electron in the sodium atom. Now my question is, so sodium atom wants to be balanced. Is it easier to receive 7 more electrons or to give out 1 electron? Which one is easier?
To give out 1 electron.
To give out 1 electron. So if sekarang niya 4 side niya electrons dane in the outermost shell dane lo salah. Sekarang niya 4 side ya lo salah. Senya 4 side ida uang ini. Então ini ihaklarannya balance ini the valutena. So it's already balanced, right? So so because it is giving an electron or losing an electron, you have the symbol of positive. When you have a positive, you call that a cation. It needs to lose 1 electrons. That's why we have positive 1 over here. Okay, that's why we have positive 1. All right. So the same thing with chlorine atoms. Okay. Paulo Sarmento. How many valence electrons is in chlorine atom? Paulo Sarmento. Are you here with us, Paulo Sarmento?
Yeah.
Yes. How many valence
Yeah.
electrons is in chlorine atom?
7.
7. Okay. Paulo, is it easier for chlorine atom to receive 1 electrons to balance or giving out 7 electrons? Which one is easier for chlorine? To receive 1 or to give out 7?
Receive.
Receive how many? It is easier to receive 1 electrons. Now, Elizabeth Suarez, are you here with us, Elizabeth Suarez? Where is Elizabeth Suarez?
Yes, sir. Yes, sir.
Okay, when an atom receives an electron, what do you call that? What ion is that? When atom receive an electron, what do you call that?
Receive an electron.
Yeah, is it cation or anion when receiving an electron?
An ion.
Gaining an electron is
An ion.
an ion. Why? Because it is a negative charge. Okay.
Negative.
If you gain an electron, you have a negative anion. Okay, good. All right. So comprende na sa mga ions to? Any questions? Awesome. So now let's study about ionic bonding. So basically, ionic bonding o hindi tadi ang bonding entry between a metal and a non-metal, right? So basically, if you look at the for example, if you look at the sodium atom and a fluorine atom, okay, sodium atom has positive 1. Why positive 1? Tambah sa naman sodium atom is positive 1. Tambah, yung valence electron is 1 lo segala. 1 anto diakliun niya 4. Diakliun niya 4 sada. 4 sai electrons ida. Fluorine yung valence electrons siya hira. Ya hit 2. Lo segala. Atau balance dia precision tandit electron ida. Atau balance dia kan dia precision tandit electrons ida tambah ne maka sodium bahira sodium ida ne ni 4 gratis dia. Ni electrons ida ne ni 4 dia ba fluorine. Então sodium mas balanço na. Fluorine mas balanço. Fluorine iha walu iha ne. Sodium mas iha walu ida ne. Agora sodium ne kan metal. Fluorine ni kan non-metal. Anto ida ne 4 gratis trit ya. Também ne maka kebenaran ionic bonding ne. Maksudnya 4 trit ba na ba? Ada ito? Ne kan sirara forma na sodium fluoride. Ne bahira sirwa halo ligação ne. Ne bahira átomo sodium ne basic ba átomo fluorine mau tira mau sinal tem que ia bonding. Tem que halo ligação. Delia Diva Valentina ne Diva. Diva, are you with us? What about Rosario de Souza? Rosario, are you here? Okay, Rosario, I want to ask you a question. Tamba sa ida maka atoms ni halo ligasan. Why do atoms do bonding? Rosario. Tamba sa ida ma atoms ni tenki halo bonding, precisa halo bonding. Tamba sa ida. Saya matende tamba sa ida.
Atau halo stable electrons.
Yes, ato halo stable. Electrons wants to bonding because it wants to reach stability. Kung sama ko to define stability, Amelia. Mahirap ta kolye atoms to reach stability ni tuir rule sada. Amelia. Atom ida
Yes, sir.
atomus ida to reach stability ni tem que halo tuir rule sada. Ya rule rua. Amelia hatene galay.
Attendance, sir.
Sama hatene.
Yeah, two rule, octet rule and two rule.
Duet rule, octet rule, and duet rule. Very good. All right, so that's what an atom is. So if you look at the sodium and fluorine, sodium just give us 1 electrons, and then that's what ionic bonds is. So for example, if you have bonding between magnesium and chlorine, agora magnesium ni kan positive 2. So if you look at magnesium, ito bata periodic table ito ohing hawaturo ne. Magnesium ni ano be? Magnesium ni man ito. Niya valence electron is positive 2. Pues niya bonding ho chlorine, magnesium o chlorine. Chlorine niya valence electron niya 7. Agora how usufali entre magnesium niya gampang liu ato simu hituga simu 5 ga wait 8, right? So 2 you already have 2, you need to receive 5. So magnesium niya gampang liu ato simu sada nenga niya fosai rua. Gampang liu ba magnesium ato fosai rua loh, right? Karena sama so chlorine. Chlorine kan ya valence electron itu. Ini gampang juga chlorine atau simu electrons ide do kenya fosai electrons itu. Ambilnya maka ini hari magnesium ho tamannya mau hari magnesium nih ya plus 2. Plus 2 nih tamannya karak atau 4 electrons rua. Losing 2 electrons. Chlorine means satunya tamannya karak gaining 1 electron. Selesai. Ini hari ya nih. Ini kan magnesium nih ya rua. Magnesium nih kan precisa lakong átomos, electrons rua to. Então, por exemplo, se tinha 40 electrons ida ba chlorine ida ne, chlorine ida ne balanso na maybe niya sa iya extra ida, niya sa iya resto ida tang. Então, niya fotang ba chlorine ida tang, gusto? Niya 40 ida ba ihane, niya fotang ida ba ihane. Então, magnesium 40 na rua ba chlorine. Também ne may itahakerek Mg nene, Mg2 Cl. Nabi mahker magnesium chloride kerek ni mahker. Nabi bahira sira forma kari bonding niya nasa ne. Nebe sira halo ligação niya nasa ne. Nebe sira forma karik niya formula química karik. Magnesium chloride. Okay, so that will be Mg2 or MgCl2, yeah. MgCl2, not Mg2, yeah. MgCl2 nasa ne. Cl niya katak niya iya chlorine rua. Iya chlorine rua iya magnesium ida. Forma mutuk forma magnesium chloride. All right, that's what ionic bonding is. Any questions? Preguntas, Ruma? Any question about ionic bonding? Ya, preguntas, Ruma? Ya, kono ba ionic bonding? Okay, sila iya. Ita be, how buka talk be? Let's ionic bonding simulation room online invite. Let's see any simulation online about ionic bonding. Okay, so there is a FET simulation. Wait, there is no simulation. I want to see ionic bonding. Oh, the name for polymer. Okay, both Java Lab. Hopefully Java Lab works. Simple chemical bonding. Okay, ano sa kayo tadi yan eh? You have a sodium atom bonding to a chlorine atom. Masyado may emotion lah halos simulasan dia kita palit halos treated like ionic model. How do I do this? All right. So, por ejemplo, nessa neto, por ejemplo, se mi foti be aluminum 3 plus, no sei lá, niya kan tolo. Então, se niya halos ligação ba iha chlorine, então niya precisa forhira, niya aluminum ho chlorine, lo sei chlorine means 1 aluminum 3 plus. Então, aluminum niya precisa fosai tolo, berarti niya precisa chlorine tolo. Chlorine ida tan, rotan chlorine ida tan. Nema foi bele forma bonding ida aluminum, nema foi forma aluminum chloride, so AlCl3. All right? Okay, por exemplo, fali se kare imi ia fali imi akara kalo be calcium positive 2 akara kalo bonding ho oxygen, no zalai? Então, ruane rua, jadi calcium ne fotomak tede nini rua ba, kamu tuh siro jari balas ten, balance ten. Basta calcium ho oxygen ano sabemos balanso na. Basta? Por exemplo, imi bonding fali entre copper, fotan seda, copper iodine. For example, copper ho nitrogen, for example. Agora, copper ho nitrogen, okay? Nitrogênio ne precisa simultan. I don't think that's gonna work, but let's try. Nitrogênio ne precisa tan hira. Ne precisa tan tolo, copper ne rua para tu fo. Ne beba hira serua ne halo ligação insa. Copper foluk te rua, hane sane. Lo sal mebe ida ne se folte precisa tan ida. Lo sal Nai. Agora ne o insama ne. Tiri mini ano o insama copper hobe nitrogênio bale bonding. Any guess? Okay, por exemplo, copper ne kan ne folte rua ba ida ba. Tapi nitrogênio se precisa tan ida. Então, o tem que fotar copper ida tambah. O fotan copper ida tambah. Agora nitrogênio be ni copper ida resto te faliona. La vele, la salai. Então, tem que aumenta tanto nitrogênio ida tan, vai tanto que ne. Okay. Então, o site ne, então tem que aumenta tan copper ne. Então, se nessa ne kan balanso na. Berarti niya se forma hira Cu ia Cu ne tolo and nitrogênio ne rua. Então, Cu tolo nitrogênio ne rua. Nebe imi hare kare copper nitride, CO2 and 3. Okay, so basically this is copper nitride. All right, so this is a good model. I like this one. Okay, let's say, for example, let's say semafotok atom silital kokotok bonding ida. I wanna just pick a metal and a non-metal. Okay. Any of you pick one metal, whichever one you want. Any of you. Amelia and Egala, Amelia.
Yes, sir.
Wait, do you guys still see my screen? Im share how you share Negala.
Yes, sir, Sarela.
Okay, Amelia Hili talk non-metal ida. Just pick one non-metal. Narang hili dari. Sira nene tu hili akar hilan be.
Hmm. Ini
Let's say you pick sulfur, okay? All right, I have sulfur anions. All right, Rosario de Souza, can you please pick one cation? Rosario de Souza, narang hilito
Yes, sir.
cation nila. Ha? Saan na, Rosario?
Magnesium.
Lorona.
Magnesium.
Oh, magnesium, for example. Sekarang niya magnesium plus 2, negative 2, Antone langsung magnesium ne for langsung to sodium charnamne perfectly fit. Lazare? Perfectly fit. Se, por exemplo, niya hilifali aluminum, for example. Antone senaro winsafali. Winsama ka aluminum ne, halo bonding host aluminum 3 plus ni halo bonding host sulfur ne. How? Elizabeth.
Add one.
Kira? Kita tahu sulfur ne ba aluminum. Oy, Antonio ne aluminum se falta electrons ida resto, lo salai?
We add one ni teacher.
And then we add one more sulfur. Maybe kita add one more sulfur, agora sulfur ne se precisa tang extra one over here. So you need another aluminum over here. Okay, and after you add another aluminum, you make 2, so you need to add another sulfur over here. So you will have 3 sulfur atoms, 2 aluminum atoms to form a bond. We call it aluminum sulfide, or Al3S2. Okay, if you look at the material, yeah, this is the aluminum sulfide. Aluminum sulfide naman material, aluminum sulfide naman Al2S3. Or if you look at the graph here, this is like white powder or something like this. Aluminum sulfide. Agora usually, baby, in theory, cement. What is the chemical formula of cement? Theory na side makabiasa bonding ne. May cement ne elemento kimika side makaya cement. Sematene. It's between calcium and oxygen, yeah. We call it calcium oxide. So calcium bonding to oxygen, that's what you call lime. Calcium oxide or lime. This is calcium and oxygen. So if you look at the calcium oxide, if you go CaO, this is your cement. Namanya cement naman, that's calcium oxide. That's lime. Obviously, the composition mo si cement nene bara kituan si bay maybe mayoritas ne makita ne. Let's say cement composition. What is the composition of cement? Okay. Composition of cement is 30 to 40% is lime. Lime o hindi mas CaO ne. Ini harela on screen nila.
Yeah.
Okay. So basically, composition which is cement naman eh. So basically, you have calcium, which is calcium oxide or lime. It's about 60 to 67% is calcium oxide, and then you have silica or silicon dioxide, and then you have alumina. Then you have iron oxide. You have magnesium oxide. So these are all the composition of cement. Yeah. You have cement tipo sera mana ya? What is the type of cement? Cement tipo sera. Cement biasa mo dyan na nasa.
Cement tonasa.
No, tonasa ni brand niya nara. Types of cement. Portland cement, yeah, cement Portland, yeah. Portland cement, ne inventa ya Amerika, rai narang Portland, Oregon. Okay, Portland cement. Portland cement makanya babang yang mauza ya Timor, I think. Okay, yeah, so this is Portland cement composition. Composition of Portland cement is what? Okay, you see? So you have trice calcium silicate. Okay. Portland cement yung composition naman eh. Yung silicon dioxide nemos ionic bonding. Calcium oxide nemos ionic bonding. Aluminum oxide nemos ionic bonding ito. So if you look aluminum oxide, right? O yung calcium oxide, natin. Ako ito bonding file ni aluminum o oxygen. So you need to have aluminum and oxygen, right? For oxygen, you have aluminum na, you have 3. Então, aumenta tiyang aluminum 2 hene label. Então, aumenta tang oxygen in datang. Label, aumenta tang aluminum in datang. Aumenta tang oxygen ya paso. Jadi aluminum oxide. So Al 2 aluminum atoms, 3 oxygen atoms. So Al2O3. Nemo salah satu komposisang ida husi cement, Portland cement. You have sulfur oxide, magnesium oxide, ne persen be kikwa. Maybe mayoritas persen mi harene calcium oxide. That's the majority composição aqui be Portland cement mayoritas ne calcium oxide ne. E depois se me cara hatene calcium oxide ne halusi saida. Se me hatene CIO ne. Halusi what you call it calcium carbonate. Calcium carbonate, CaCO3. CaCO3 ne ihane be ia fato kine bolnaran calcario, limestone. Limestone ia timor ia baucau barak los. Tamane manatoy marakar be. Atu lokes pabrik cement ia baucau ne tamba ia be fato be fato siran sanene. Fato siran sanene, that's where limestone is. Okay, for example like this. This is limestone, yeah. Nebe abang beru imi lakoy sa arkitektura imi teturet fatok founded limestone para mahalo cementimos hetang osaman. This is limestone, yeah. Calcium carbonate. E depois ema processa calcium carbonate ne maka forma fale calcium oxide ne maka sai cimento. Silicon Antonio silicon ini raihenek, yeah. So silica sand. Ne mane silica sand ne mane ne raihenek sila ne be silica ne mota barakos. Raihenek sila ne mota barakos. Nene composed to which is silicon makbarak elaran. Okay, but osira to have leten ita se estuda con ba ciencia cimenti o insama cimenti ne halo bonding by have way o insama halo nabana we will study about that, all right? We will study about all of that, the chemistry of construction. Dal rumor sila be estuda con ba materials, for example be tamasay na bamboo ne tos. Imi ne por teacher hanoring imi ta diam bamboo ne ni tensile strength makasli base ito. Terus kale. Teacher Rogeri pernah kuliah sering kale? Imelda.
Sure.
Ebe imi pernah estudo na be arkitektura kelas ni mi estudo kono ba ema halo building uja bambu kale.
Ya, ami estudio, mas bem sure. Karik essa bambu ne tala iha hal tratamento at treatment rumah, bambu ne se atla is kasa ni ular ne hanya ne sa la kleuret, ni asa lahu gepes ni asa dorok to har
Right.
sa uma karik ta har la isa.
Okay, tambah tratamento ne masay da Imelda. Tratamento insa.
We don't know, sure.
Yeah, that's why you study chemistry.
Yeah.
You can know. Actually, you can. Actually, it's a very simple process.
Yeah, later we'll know
It's a
lah.
very simple process, right? Tama sayda. Tama bahira o halo tratamento ba bambu ano so yung Imelda dihan. Então nebe ni analyze de. Então processo tratamento ne maboldar reação química. That's a chemical reaction. Basically, all you need to do is you submerge into a water so that okay, bamboo treatment for construction. Treatment. Okay, Google, let's do a quick Google search, okay? Now, once a bamboo poles are, they should be treated while they're swinging and completely dried out. Most of the giant bamboo species are suitable, but they should be treated with bitter salt like boric acid and borax. Boric acid is just boron and some hydrogen, or borax. Okay. Agora ini arquitectura nene teacher menciona gale. Ini tensile strength be bamboo ne hira. Does your teacher mention the tensile strength of bamboo or steel for that matter? Ini tone na baga sila be. Hello, arquitectura siya ni.
Structure.
Materials ni misdak building technology misdak fotiga.
Yeah, I'm 40 sure.
Anto imi la estuda ko na ba tensile strength siya ka?
Yeah, momentum ba mela mistura to ne bara tamba. Tempo bara kliwan tahu a mistura sa balon de.
Tensile strength ni iya design analysis most. Iya design analysis. Okay, design analysis 1 and 2. Info siya.
Foto to na sure.
Okay, design analysis ne pasti mistura ko na ba be tensile strength siya nito of a material. I hope you do. If you don't, then I'll have another conversation with your teacher. Wait, does your teacher ever mention about tensile strength? Ini profesor arquitectura pernah mention ako about tensile strength kali. Paulo Sarmento, Rosario, Anivio. Ini tona na bena. Okay, tensile strength of bamboo ne mane around about 1,400 psi. Kata niya bele bamboo ne bele simu toran to 1,400 psi, yeah, or in equivalent of atmospheric correct here mane. It's about the megapascal. It's about 220 megapascal. That's very good material, yeah. So bamboo has about 220 megapascal. What about steel? Steel is about, yeah, steel is about very, very good. So steel is about 700 to 860 megapascal. That's what tensile strength is. Wait. All right. Perguntas, Roma? Ahora si mi baru tur kelas atau namanya.
Nice sure.
All right, that was ionic bonding. Next meeting we will do covalent bonding. Yeah, I think for materials, materials for architecture. Models. Okay, so you have basswood sheet. Reflection rasanya bebe memang fangi timur ya kak. Ini halo model sel sana nih. Game is sosar ya tim halo rasik.
Balon dit ma iya sure. Balon lah ada material itu buka rasa.
Ini biasa sosar nih biasa.
Dia sesuatu iya.
Betul.
Lo aja sana balu ya.
Ini precisa hakarak sosar rumah husi irailiur kali. Por ejemplo, nessa sosar arquitecturanya husi Indonesia, husi Malaysia, husi Amerika, atau Gloria Timor. Terserah mi precisa. Se mi hakarak imi bela tahu mutu kosan, estudar escola JSU bela ajuda imi sosa. Material tercera. Maybe mi precisa. Ah? Ba imi usa personal, o sa to escola lá. Usa ba imi projeto sera imi ba. Será? Por exemplo, nessa lápis, specific lápis rumah, régua rumah, surtan specific rumah. I don't know.
Iya, hampir sih ya sara juga skala sana sure.
Regua skala.
Yes.
Ini man sana scale ruler for architectural drawing. Terus sana bene. Ida sa triangle na sana ni kalos.
Yes, triangle na siya.
Ano sa auto ka
Gimana?
foto na niya?
Yeah.
Ini $10 itu.
Ini TPI ya.
Ini TP ya kah?
Tapi lahara siya. Buka tower lahetan.
Ani video yang ini sosial drawing.
Tapi kan kayaknya iya pas sama heteng ya lah nih.
It costs about
Bawah.
$10 here. This is good, not bad. Idan ededa, imprecision idan ededa. Architectural ruler, yeah, that's okay. All right, we are out of topic already.